Welcome to this tutorial video. In this video we're looking at Dijkstra's algorithm. We're looking at a particular weighted network here and we're trying to find the shortest path from vertex A to vertex F. Now, looking at this from inspection, we can see pretty clearly that 3 and 7 gives me 10. A weighted path from A to B to C is 10. That looks about the quickest way to get there. From A to C is 6, plus another 5 would give me 11, and the rest would give me more. So we can see from inspection with this relatively small network that the answer is 10. But in the more complicated networks, we need a process, a step-by-step plan, which we call an algorithm. And it was invented by a gentleman by the name of Dijkstra, a process that always, without fail, delivers the shortest path. So let's have a look at this example. First of all, we're going to start at A with a table here with all the other vertices labelled at the top of the columns. So B, C, D, E, and F. So from A to B, that has a weighting of 3. From A to C, there is a weighting of 6. From A to D, there's no direct line. Okay, one single link, so there's nothing. From A to E, there's no link, so there's nothing. We put an X in, and from A to F, there's no direct link with one step, so there's nothing. Now we look at these and we identify the smallest number, which is 3. Okay, now 3 is occurring in column B, so that then becomes our next row. Okay, we take the smallest number in the previous row, look at the column, which was B, and that becomes the letter heading for our next row of our table. Now we're looking at, and by the way, that stays as the shortest length from A to B is 3. That is now got a box and locked in. Now we're looking from point B to C. Okay, so from B to C, we have a length of 4. However, we've already travelled from A to B with 3, and on top of that, we're adding from B to C now of 4. So in total, that 3 plus 4 gives me 7. Okay, so this is saying from A to B to C is 7, the shortest length that we've got so far. Now from B to D, oh by the way, that 7, if we look here, isn't actually the shortest at all. We previously identified that A to C was 6. Okay, so we record that as 6. We don't use the value of 7 because it wasn't the shortest length. Now from B to D, there is no link, so we put an X in. From B to E, there is no link, we put an X. And from B to F, there is a 7 edge. Okay, but again, we're starting from A, so A to B is 3 in the box, plus another 7 gives me 10. Okay, so A to B to F gives me a total of 10. We identify again the smallest number in that particular row, and it comes from column C. So C now becomes the third row in our table. The squared value remains, okay, of 3. The square, we put a square around what was circled in the previous, so that is locked in. Meaning from A to B, the shortest distance is 3, and from A to C, the shortest distance is 6. Now, from C to D. C to D is 6. However, I've already taken 6 to get from A to C. Okay, the shortest distance from A to C is 6. A to C is 6, plus another 6 gives me a total of 12. C to E, not connected. And C to F gives me a total of, from A to C was 6, and then from C to F is 5, gives me a total of 11. However, we can see previously we've already got from A to F via point B with a total of 10, so that 11 is discarded and we remain 10, the lowest number goes in there. Okay, now that 10 is in fact the lowest number now in this particular row. It occurred in column F. So F now becomes the next row of our fourth row in this table. So from A to B still remains locked in at 3. Shortest distance from A to C is 6. The shortest distance from A to F is 10. Now we continue on. F to D. F to D has, so from F it took us 10, so it was 3 plus 7 is 10, plus another 2 would give me 12. Now notice, that's the same as A to C to D. Okay, from A to D was a 12. It's exactly the same distance, so you can accept that. You just put it in as 12. That's not a problem. We can consider either path. That gets locked in. And from F to E, we've got from A to F was 10, plus a further 9 gives me 19. Okay, now of those numbers that aren't in squares already, 12 is the smallest number. Okay, so D is the column that 12 operated in, existed in, so we take D as our fifth row. Now, and that 12 has a square around it, it's locked in, so A to D, the shortest distance is 12. We haven't got many left. So from D to E is a further 8. Okay, so we worked out that it took 12 to go from A, the shortest distance around, to D. A to B is 3. B to F is 7, that's 10. Plus another 2 is 12. Or alternatively, A to C to D is 12. Plus another 8 gives me 20. Okay, so we can get from A all the way around to E in 20. However, we realized that earlier we could do that same process. 3 plus 7 is 10 plus 9 is 19. So this table, we always put in the shortest value. So we discard what we had previously with the 20 and we lock in 19. Now we've got the shortest path for all of them. Okay, let's examine each one of these. Now this technique of moving along the rows may be a bit confusing, but let's have a look. What we do is we look at this particular square. It's got a number 3 in it, and we follow that up the column until we reach any change. Well, it goes all the way up to A. Okay, so I've gone from B all the way to A. So that's the way of saying A to B, working backwards. A to B is the shortest distance, and it has a distance or a weighting of 3. Let's look at now from column C. So C starts with the 6. We go all the way up till it changes. It doesn't. It goes right to the top, and then we go across to A. So A to C represents the length or the weighting of 6. Now this one's our first different change where we've got a few different connections. So 12, we're in D now. We're looking at our length between A and D. So we start at D in column D, and we go up till we hit the last number that's the same. So 12, 12, 12, 12. After that, we've got this X with no connection. 12 is our last one. Now, if we go across, that occurs in row C. So we follow with this blue line across to column D. We'll repeat that step again. This last number 12, as we move up in the column D, occurs in row C. So we move across to column C. Now we continue going. That's number 6. We continue going up, and it takes us right to the end. The number doesn't change, and across again to A. We always finish with across to A as our end result. So looking at the red lines, we've gone from D to C to A. D to C to A. So in reverse, it's A, C, D with a weighting of 12, 6 and 6. Our next one, this looks a bit complex, but let's follow it again. We're looking how do we get from A to E in the shortest possible path. So we start with 19 in column E, and we go up till the last 19 before it changes to an X. Now that's happening in row F. So we move across to column F, okay? That last 19 happened in row F, so we move across to column F. Now we keep going until that number is the last one before it changes. That's a 10, the next one is an X. This occurs in row B. So we take that all the way across to column B, and we take that up. It's the same number, it hasn't changed, but we've reached our last particular row, so we go across to A. So we went from E on the red to F on the red to B to A, or in reverse, A, B, F, and E. A, B, F to E, and it has a weighting of 19. Finally, let's look at F. We start with 10, and we keep following that all the way up till we get to our last 10 before it changes. This last number occurs in row B. So we take it across with the blue line all the way across to column B. Okay, that 10 has occurred in row B, so we switch across to column B. And this number we take up till when it changes, or it takes it right to the end. So it goes across to A. Remember, our last one always cuts across to A. So working backwards, I've got an A and a B with our red, and then an F. A to B to F, and it's got a weight of 10. Hope that makes sense. Our comparison of finding the shortest path using Dijkstra's algorithm. Keep practicing, work hard, and enjoy your mathematics. And of course, thanks for watching.